we judge whether milk, ghee, butter, salt, spices, mineral water or juice that we buy from the market are pure? Have you ever noticed the word pure written on the packs of these consumables? No. For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of a single type of particles. In other words, a pure substance is a pure single form of matter. As we look around, we can see that most of the matter around us exists as mixtures of two or more pure components. For example, seawater, minerals, soil, etc. are all mixtures. So, on the basis of physical state, matter is classified into three main types. They are the solids, liquids and gases. Whereas on the basis of chemical composition, matter is classified into two main types. They are pure substances and mixtures. Pure substances are of two types again. They are elements in compounds, whereas mixtures are of two types, which is homogeneous and heterogeneous mixtures. So what are the differences between pure substances and mixtures? Pure substance consists of a single type of particle, like I just said now. They cannot be separated into chemical constituents by physical methods, and pure substances has its own definite properties. Whereas mixtures consist of two or more pure substances. Mixtures can be separated into its components by physical means, and they show the properties of its components. And like mentioned before, mixtures are of two types. We have the homogeneous and the heterogeneous mixtures. Let's see each one in detail. Homogeneous mixture is a mixture which has a uniform composition and the particles of the mixture are not visible by the naked eye. The particles cannot be separated by filtration and the mixture is stable, that is, the particles do not settle down. The path of a beam of light is not visible in a homogeneous mixture. Examples are mixture of sugar in water, mixture of salt in water, mixtures of copper sulfate in water, etc. The second type is the heterogeneous mixture. This is a mixture which has a non-uniform composition, and the particles are visible by the naked eye and the particles can be separated by filtration. The mixture is therefore unstable because the particles settle down when left undisturbed. The path of a beam of light is also visible in the case of a heterogeneous mixture. Examples of heterogeneous mixtures are mixtures of sand and salt, mixture of sulfur and iron fillings, mixture of oil and water, the most important example, etc. Now we shall discuss about what are solutions, suspensions and colloids. A solution is a homogeneous mixture of two or more substances. You come across various types of solutions in your daily life. Lemonade, soda water, etc. are all examples of pure solutions. Usually we think of a solution as a liquid that contains either a solid, liquid or a gas dissolved in it. But we can also have solid solutions, for example alloys, and gaseous solutions like the air. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that the particles of sugar or salt are evenly distributed in the solution. Now, a solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent, and the component of the solution that is dissolved in the solvent, which is usually present in lesser amount, is called the solute. Here are some of the properties of solutions. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer. So, they cannot be seen by the naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution. So, the path of light is not visible in the case of a solution. The solute particles cannot be separated from the mixture by the process of filtration. and the solute particles do not settle down when left undisturbed, which means a solution is stable. So we understand that in a solution, the relative proportion of the solute and the solvent can be varied. Depending upon the amount of solute present in a solution, it can be called dilute, concentrated or a saturated solution. Dilute and concentrated are comparative terms. At any particular temperature, a solution that is dissolved as much solute as it is capable of dissolving is said to be called as a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called as a saturated solution. The amount of solute present in the saturated solution at that temperature is called as its solubility. If the amount of solute contained in a solution is less than the saturated level, it is called as an unsaturated solution. So now, the concentration of a solution is the amount of solute present in a given amount of solution, or the amount of solute dissolved in a given mass or volume of solvent. As an equation, we can say it as concentration of solution equals the amount of solute divided by the amount of solution, or the amount of solute divided by the amount of solvent. There are various ways of expressing the concentration of a solution, but here we will learn only two methods. The first one is the mass by mass percentage of a solution, which is equal to mass of solute by mass of solution into 100. The second is the mass by volume percentage of a solution, which is equal to mass of solute by volume of solution into 100. Now coming to colloidal solutions. A colloidal solution is a heterogeneous mixture of two or more substances. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed phase in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersion medium. For example, mixture of starch in water or mixture of egg albumin in water, milk, air containing dust and smoke, etc. are all colloidal solutions. So let's see some of the properties of colloidal solutions. Colloidal solution, like I said before, is a heterogeneous mixture and the particles cannot be seen by the naked eye. The solute particles cannot be separated by filtration and the solute particles do not settle down, so the solution is said to be stable. The particles scatter a beam of light passing through it and the path of light is visible in the solution. Colloids are classified according to the state, whether a solid, liquid or a gas, of the dispersion medium and the dispersed phase. A few common examples are fog, wherein the dispersed phase is liquid and the dispersion medium is gas. In cheese, butter and jellies, the dispersed phase is liquid whereas dispersion medium is solid. Now let's see a very interesting example of a colloidal solution. When a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of light becomes visible in the solution, and this effect is called as the Tyndall effect. Tyndall effect can be seen when light enters a dark room through a small hole due to the scattering of light by the dust and smoke particles. Tyndall effect can also be seen in a dense forest due to the scattering of light by water droplets in the mist, which is very beautiful, right? Now let's see what are suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. For example, you take a solution of sand in water or solution of chalk powder in water. These are all suspensions. So coming to the properties of suspensions, the particles here can be seen by the naked eyes and the solute particles can be separated by filtration. The solute particles will settle down when the solution is left undisturbed, which means the solution is unstable, and the particles scatter a beam of light passing through it and the path of light is visible in the solution. So now to conclude, matter is classified into pure substances and mixtures. Pure substances are further classified into elements and compounds, whereas mixtures are further classified into homogeneous and heterogeneous mixtures. True solution is an example of a homogeneous mixture, whereas colloids, suspensions fall under heterogeneous mixtures.